Hello everybody, the topic of this section is Other Projects Analysis. In this section, we will discuss projects with different lives and rank mutually exclusive projects. Firstly, let's see projects with different lives by example. Suppose a firm is considering two types of equipment to automate its production process to save on labor costs. The first one costs $2 million and has a life expectancy of 5 years. The second one costs $4 million but have a life expectancy of 10 years. Compared with the first equipment, the second one costs twice but lasts twice as long. For the decision which one to choose, it is important to find how to make the two investments comparable given that they last for different periods of time. One approach is to assume that the first equipment will be replaced at the end of 5 years with the same type of equipment that will last for another 5 years. Both alternatives will then have the same expected life of 10 years. For the first one, the present value of its costs is PV1 is equal to $2 million plus $2 million divided by 1 plus I to the fifth. For the second one, the present value of its costs is $4 million. Now these two types of equipment are comparable based on the present values of costs, and it is better to choose the one with smaller present value of costs. However, if the life expectancy of the second equipment is 12 years, which is not a multiple of the life expectancy for the first one, how to do the comparison? An easier approach is to employ a concept called annualized capital cost. It is defined as the annual cash payment that has a present value equal to the initial outlay. The alternative with the lowest annualized capital cost is the preferred alternative. In our example, at a discount rate of 10% per year, setting the $2 million initial capital outlay equal to the present value of 5-year annuity, it is found that the annualized capital cost of the first equipment is $527,595. By the similar arguments, the annualized capital cost of the second equipment is obtained as $650,982. Because the first equipment has a lower annualized capital cost, is the preferred one. Following this example, here is a quiz. What would have to be the economic life of the machine that costs $4 million for it to be preferred over the machine that costs $2 million? Take the economic life of the second equipment as an unknown parameter n and set the annualized capital cost of the first equipment, $527,595, as the one of the second equipment. Solving this equation, the n is obtained as 14.89 years. This suggests that to be preferred to the first equipment, the second equipment would have to have an economic life longer than 14.89 years. Rounding to the nearest year, we get 15 years. That's about two projects with different lives. Now let's see how to rank mutually exclusive projects. Sometimes two or more projects are mutually exclusive, meaning that the firm will take at most only one of them. For instance, a project requires exclusive use of the same unique resource such as a particular parcel of land. In all such cases, a firm should choose the project with the highest NPV. Let's see an example. Suppose that you own a parcel of land and have two alternatives for developing it. The first one is that you can construct an office building on it, requiring an initial outlay of $20 million. The second one is to make a parking lot out of it, requiring an initial outlay of $10,000. If you build an office building, you estimate that you will be able to sell it in 1 year for $24 million. In this case, the internal interest rate IRR is IRR1 is equal to $24 million minus $20 million divided by $20 million, that is 20%. If you make it into a parking lot, you estimate that you will have a cash inflow of $10,000 per year forever by the formula for the present value of perpetuity. 10,000 is equal to 10,000 over IRR2. Then solving this equation, the IRR2 is obtained as 100% per year. Which project should you choose? Even though the parking lot has the higher IRR, you would not necessarily want to choose it, because earning $4 million once looks much better than earning $10,000 per year. This means the scale of the parking lot is small compared to the office building. In conclusion, since a project's IRR is independent of its scale, IRR is not a good measure for ranking mutually exclusive projects. However, the NPV is a better one. This figure shows the NPV profiles of both projects. NPV plotted as a function of the cost of capital. The discount rate, which is the project's cost of capital, is measured along the horizontal axis, and the NPV is measured along the vertical axis. The discount rate of 20% per year is the critical switchover point for the two mutually exclusive projects. At any discount rate above 20% per year, parking lot has a higher NPV, and at rates below 20%, the office building has a higher NPV. This example suggests that the NPV is a good measure for ranking mutually exclusive projects. In summary, in this section, we have discussed that for projects with different lives, we should choose the one with lower annualized capital cost. Besides, we should choose the project with the highest NPV among mutually exclusive projects. That's all about this section. Bye.